Okay, so you guys can see exercise number 1, right?
Yes.
Yes.
Anyone not able to see that? Okay. So here we're talking, the section 1.1 is about functions and representing them different ways. And so here's one way to represent it with the graph. And it's asking for the point f of 1. So you come over here to 1 right here. So 1 is like right here. This is 1, and then you find out what the point is, and that's up at, that looks like a 3 right there. Okay, so that's going to be 3, and then f of -1. Anybody want to give an estimate for f of -1? That's over here.
For the estimate value, right?
Yeah, it says estimate the value. It looks like it's not going to go through, it doesn't go through anything specific. And they messed up these graphs, so I can't really point at it. It's right there, though. It goes through right there.
Yeah, I entered mine and I put -0.2, and it says it was correct.
-0.2?
Yeah, -0.2, like .2.
It looks like 0.3 to me, but okay, if you got it right, then actually maybe it's something like that. Okay.
Yeah, probably.
Wait, how did you I mean, that's a really approximate answer. How does it, oh, it shows up on the graph, the 0.2? Because like it's not like there's little
It doesn't show up on the graph.
Yeah,
it doesn't
Yeah,
show
it
up on the
doesn't.
graph.
I guess you just have to estimate.
Okay.
It's gonna, if you put anything between negative, I'm guessing if you put anything between -0.1 and -0.4, it's gonna accept it.
Okay.
You can like test around different values and see what it accepts and what it doesn't. Okay, so part C, for what values is f of x equal to 1? Okay, so here you go right here. This is 1 right here. This horizontal line there. And it looks like it goes through here at 3 and also at 0. So we're going to put 0, 3. And then where is it 0? What is that? Right here. It goes through 0 right here. So anybody want to guess? -0.7 maybe?
Yeah, 0.
Okay, the domain is a set of x values, and since it goes from -2 up to 4, right? And the range is the set of y values, and that goes from, so the y values is from -1 all the way up to 3. Okay, now increasing and decreasing is determined by the left to right motion. So as you're going from left to right, what's happening with the graph? And as you're going from like -2 to 1, it's going up. So that's going to be the increasing. Okay. And decreasing everywhere else. Okay. So any questions about that? So that's like number 1. And then like this, like I said, this value and this value, there's some leeway there. You can put, you just have to estimate it and get it within a reasonable amount. Okay.
So for interval notation, does it require us to put the brackets in? If we don't put it in brackets, will it mark it wrong if it's asking for interval notation?
Yeah, it'll mark it wrong if you don't put the brackets.
Is this supposed to show the answers once you're, like if you got it right or wrong once you hit submit? Because I hit submit answer and it's not telling me if I got anything right or wrong. Oh, there we go. I don't know what happened. It was just delayed.
The green check mark means you got it right, and if you get a red X, that means it's wrong, apparently. I've never done that, so I don't know. Okay, so number 2, you have the graph here, and it's asking whether it's a function or not. And what do you guys think? What do you think? It's the vertical line test that determines whether something's a function or not.
No.
Yeah, it's not a function. So then right here, then NAF. I wonder what NAF stands for. They just put that in there if it's not a function. Okay, so that was number 2. Number 3, we have one that is a function because it does satisfy the vertical line test. See here, the problem is that a vertical line passes through more than one point. Okay, but here that doesn't ever happen, so this is a function. And then again, the domain is the set of x values, which is going to be -2 to 2, I believe. That's -2 right there. I can't really point at this because this thing comes up. -2 to 2. And then the range goes from this point, this value here is horizontal, which is -1 up to 2. Okay, after this next problem, we'll be out of, we'll not use them. We'll all go out of Webassign, but I just wanted to show you how Webassign works. Okay, so let's take a look at number 4. It says sketch a rough graph of the number of hours of daylight in the northern hemisphere as a function of the time of year. So, which one do you think? Which graph? You guys want to take a guess at it?
The third one.
Yes, that's going to be that one. Because like in June is the most sunlight. Oh, where's my red check? My green check mark. Oh, there it is right there. Okay. Okay, so so that's Webassign for you right there. Now, typically, what's going to happen in class is I'm not going to be in this one. But rather, I'm going to be in this document. So I've created this PDF document. Let me bring my, I have to put the chat up every time. Okay, so I've created this PDF document, and we will use that to go through everything. Okay, so let's see, what have we done so far?
Sorry, do we have access to that PDF, or is it just something that you'll pull up in class?
Oh yes, I will upload these. I'll upload these to files in Canvas. I'll create a folder in Canvas.
Okay.
And I'll upload these to that folder.
Okay, and then will they show up before class then? Or is it going to
yes,
be like?
I will. Okay. Yeah, I'll try to show it up. I'll try to put it up before class. But the before class will be, and then I'll try to, and then when we finish class, because when we do class, I'm going to mark this up. And so
Okay.
when we finish class, I'll upload these as well. Okay. So there's different ways of looking at a function. One is verbally by just like a description. And then another one is numerically with a table of values, visually with a graph, and algebraically with an explicit formula. So the formula would be something like this, or that. That's the one with the formula, and that's probably the one that you're most used to. And then we also saw a lot of graphs on the homework that we just did. But a table can also describe a function, and just verbally can also describe it. And so sometimes, you know, some problems are like you take a verbal description and you put that into a formula, or you put that into a graph, or both. Okay, so let's see, we did exercises 1 through 4, and that's talked a little bit about those. So number 5 is they give you this function here, and you're supposed to find the difference quotient. And this is something that happens a lot in calculus. This is the fundamentals of the derivative, is the difference quotient. That's like the fundamental part of the derivative and calculating derivatives and what it is. Okay, so we're supposed to figure out what that is. Okay, so the idea is you just put everything here that's there. Now this is f of 4, and this is f of 4 plus h. So f of 4 plus h, so when you have a function, you have this x, and then you have these x's here, but this x here got replaced with a 4 plus h. So everywhere that you see an x here and here, then you have to replace it with a 4 plus h, like that. Okay, so it's just like plugging the stuff in the right point. And then with this one, the x already replaced with a 4, so you have to replace all these x's with 4s. And when I do the replacement, I usually put parentheses around whatever you're replacing. So replace this x with a 4 with parentheses around it. Okay, so that's what I did there. So these x's got replaced with 4, not just 4s, but with a 4 with parentheses around it. Okay, because that helps with the operation. And then these x's, and over here, they were replaced with 4 plus h's with parentheses around it. Okay, so now the next thing that we want to do is simplify this. And then once we simplify it, then we'll put the answer in. Okay, so this is 4. Just distribute the 5, and you're going to get 20.
Wait, I'm sorry. I know this is like basically review with functions, but why is the minus x squared not yeah, wait, I'm trying to figure out how it got substituted the way that it did, like why it wasn't 4 plus h on like minus 4 minus 5 times 4 plus h. I don't know, I think maybe I'm looking at this wrong.
So it's just this right here and those two x's, because this x got replaced with a 4 plus h, right? So these x's replace those with 4 plus h's in parentheses. And leave everything else.
Oh, okay, I understand now. I see.
Okay, so everything else is left exactly the same.
So
okay,
on the,
so I just checking.
One more question. So on the second interval, so we have the 4 plus 5, 4 plus h. On the 4 minus 5 times 4, wouldn't it still be 5 or 4 plus 5 times 4?
No, the minus, oh wait, whoa, you're right, there's a plus.
Okay, I just wanted to make sure.
Okay, thanks. Thank you, yay, that would save a lot of trouble from later on, because I wouldn't know, would have got the wrong answer, then not knowing what happened. Okay, so now we have a minus, and then 4 plus h. Okay, so let me just, let me see here. Okay, so let's look at this part right here. 4 plus h squared. There's like a formula for doing that, but what I would advise is to look at it this way. Okay, so when you see a quantity like this squared, it's really it's times itself. So squared means it's 4 plus h times 4 plus h. And that means you have to use the FOIL method to work this out. So that's going to be 16. And then the outside is 4h, the inside is 4h, that's 8h. And then the last one is h squared. Now there's also a formula that you can use to go from here directly to there. So that's fine if you want to do that. Okay, so this is all minus. So I got to minus all these. So minus 16 minus 8h minus h squared. Okay, and then we'll go ahead and, well, distribute this negative in. So that's minus 4. And then this is minus 20. And this one is going to be, there's two minuses, so that's going to be plus. And then 4 squared is 16. Okay, so we had to build an extension over here like that. Okay, now this is going to be the funnest part for most everybody, because lots of stuff are going to just cancel, like those guys cancel. And then the 20s cancel, check that out. Well, there's just the 20 there and there, so those guys just go away. And then, whoa, check this out. Then these guys cancel as well. So we're just left with, what is it, 5h minus 8h? That's minus 3h minus h squared, and that's all over h. And then you can factor an h out. And then the h is reduced, okay? So let's see here. Go ahead and put that in Webassign and see if that works. Okay, so I got that, mine worked. So negative 3 minus h is the final answer. Here's another one evaluating the difference question, kind of just doing the same thing that we just did. We'll skip that one because we're really low on time. We'll go to domain. And usually with the domain, what I like to say is there are a couple of things to check for as far as the domain. Okay, so you can't, no zeros in the denominator. Okay, this is, I'm referring to when you see a function that's written down. So like right here, you can see that if you factor the denominator, you get x minus 5 and x plus 5. And so you can't have it being negative 5, and you can't have it being 5. Because if it's 5, then that won't be 0. If it's a negative 5, that's going to be 0. And so that would make it not work. Okay, and then the other one that you look for is in the square root. You have to be greater than or equal to 0 in the square root and under radical. Okay, so now to write this one, what you would do is you go from negative infinity to negative 5. That's how you exclude the negative 5. You just exclude it that way, and you exclude, and then you exclude the 5 by doing the same thing, 5 to infinity like that. Okay, and then we can see if that is going to work. And for the union sign, if you just type union, that will get it to you. And if you want to put infinity, you can find a symbol in the calc pad, or you can type the word infinity. Okay, so this right here, if you just type union, it'll produce the symbol. right here, if you just type infinity, that'll produce this symbol. Or you can find those in the calc pad and put them in that way. Okay, so let's go on to next one. Okay, so number 8, the domain and range of this function. Okay, so for the domain, I said before you want anything under the square root sign to be greater than or equal to 0. So if you rearrange this, this actually gives you x squared less than or equal to 49. And let's see. How can I explain this? This is going to mean that x has to be between 7 and -7, between -7 and 7. So that's going to be the domain. From -7 to 7. Come on, man. Okay. So that should be the domain there. And then for the range, now if you, another way to look at this is if you realize, if you look at it this way, does anybody recognize that? Does anybody recognize what geometrical object that is going to be the
I'm
graph
sorry,
of?
before we move on, why is the domain -7 to 7? I see what you
Because
did, like,
whatever you have under the radical has to be, this part right here has to be greater than or equal to 0.
Oh, okay, I see.
Because you can't take the square roots of negative numbers in this class.
Yeah, okay.
Okay. Yeah, okay, so now, does anybody recognize what this is the graph of? Well, if you square both sides, you get this, and then if you take this to the other side, you get, and that's a circle, right? And the radius is it's centered at the origin, the radius is 7. Except it's just going to be like the upper part of the circle, okay? Because this is plus here. So the minus would give you the bottom part of the circle. So that's kind of what it's going to look like. And the range will be from 0 to 7. That will be the values of the range.
Why is it from 0 to 7?
Why
I
does
get
it
the
go from
7
0?
part, but yeah. If it's a circle, wouldn't it be like from -7 to 7?
Yeah, but this is so this right here is y equals positive square root of 49 minus x squared, which is what we have. And if you go this part down here, this part of the circle would be y equals negative the square root of 49 minus x squared, which is what we don't have.
Oh, okay.
Okay. Okay, so let's go on to the next one, number 9. We're supposed to find these values and then sketch the graph. Okay, so first of all, f of -6. Here, what you do is the first thing you check for is this right here with this. This is the first thing you're going to look at. You're going to take this value here, and you're going to see where it is. So here we have a -6, and it's the first one, right? So that means you're going to use the first equation. Ignore the second equation completely. And so that's going to give you a -1. And if you do f of 0, that's going to be the second equation. So that means that you ignore the first equation completely, you just go to the second equation. And then the third one is also the second equation. So that's, you're going to just ignore, you're just going to go with those equations. Okay, now to graph it. To graph it, what you can do is you take each of these separately, y equals x plus 5, and then I'll also have y equals 4 minus x. So those are two. So this is setting y equal to the first one, and this is setting y equal to the second one. But this one also, I can write it like this, right here. Now, you know that if you have a if these are equations of lines, right? And so from here, you can actually graph it with the slope-intercept. So the intercept's 5, and the slope is 1. So that means that, you know, here, this is something with the slope of 1, right? So that's what that's going to look like, the green one, this one. And then this red one, that has slope -1 and y-intercept 4. So it's going to go through 4. That's 4. But the slope is -1, so it's coming down like this. So slope -1 means as it goes across, it goes down 1. Okay, now I'm going to erase part of this though, because let's see here. When x is greater than 0, it's the green one. So that means that all of this gets erased, and then. So let me fix that there at 5, and then when it's greater than or equal, wait, oops, I erased the wrong stuff. Dang it, undo doesn't work. Okay, hold on. Okay, I erased the wrong one because when the green one is when x is less than 0, and x is less than 0 is over here. So I'm going to erase all that. And put an open circle there. Okay, so this is x less than 0 is over here. And then x greater than or equal to 0, which is this right here, is from here on over. So that means that all this red one gets erased. Okay, so that's what the graph's going to look like somewhat. And the end of this, number 10 on Webassign, it says, I just put the equation up, but it says sketch the graph of this function. Okay, so it talks about absolute value. Absolute value is kind of important in this class, and for calculus, it's a very important concept for calculus. It's a very important tool. And the way to look at it, let me just give you a little bit of an introduction. If you have x minus a, okay, so the absolute value of x minus a, the best way to look at that would be, that is the distance between x and a. Okay, that's the best way to look at it. So right here, when you have this part of it right there, when you say the absolute value of x is less than or equal to 1, that's the same as the absolute value of x minus 0 is less than or equal to 1. So you're saying, so if you look at it this way, and then this is the distance between x and 0 is less than or equal to 1. So if you're looking at the number line, that would be, if the 0 is right here, that's going to be from -1 to 1 is what this is going to be on the number line. And this part right here where it says, you know, this one is absolute value of x minus 0 is greater than the 1. That means the distance between x and 0 is more than 1. So that means you've got points over here and points over there. Okay? So that's as far as this. There's also absolute value there. And maybe that's a little bit different. Maybe you look at that one a little bit differently. For the one over here. That one, maybe you look at it like, okay, so the absolute value function does this. Well, I didn't quite draw it that great, but let's see if I can undo. The absolute value function is going to look like that, okay? And then if you multiply by 7, then it's just going to make it steeper. Okay, and then this one is just like, and then this bottom one is just like a horizontal line at 7. Okay, and so for less than or equal to 1, so if we go from 1, -1, then that's going to be this part right here. So from -1 to 1, because of this, that's how it's going to be. And then this second part right here, it's just going to be 7 when it's beyond there. So it's going to be up here. And I guess we could just say that's 7, and there we go. So it should look something like that. The one on the last answer is correct. The one on the bottom left. Okay. So any questions about that? Okay, let's go on to number 11. Find the formula for the function whose graph is aligned through these 2 points. Okay, so lines are pretty important to know about. And if you have 2 points that are on the line, then we want to find, you should be able to find the equation of the line that goes through those 2 points. And I always let it come back to this, mx plus b. That's the slope-intercept form of the equation of a line. And so you can always just come back to this one and try to figure things out from there. So the first thing you generally want to try to do in a situation like this, when you're finding an equation of line, is to find the slope. And if you give you 2 points, then you can use this formula here. So the slope is the rise over the run, which is basically the difference in y values divided by the difference in x values. Okay, so rise over run. And then you just take, wait, this should be 1. So you just take one of these points and have that be 0.1 and the other one be 0.2. And so this is y2, this is x2, this is x1, y1. So 5 minus a -5. So this one minus that one over 7 minus 3. So that turns out to be 10 over 4, which is 5/2. So that gives us 5/2 x plus b. And then at this point, we just need to find b and plug it back in, and we have it. So you can use either point. Let's choose the second point. So we'll take this second point here, and we'll plug it in to there. We'll plug the values into there. So that gives you a 5 over here and 7 over here for that x. Okay, and 5 is actually 10/2, and this is 35/2. So b is going to be 10/2 minus 35/2, which is -25/2. And so just plug that back into here. And that should do it. Let's see here. 5 halves x minus 25 halves. Okay, any questions like that? Another thing that you can do, by the way, so there's always other options to doing these things, but let's see. Another one that you can do is you can use the point slope equation, form of the equation of a line. So y minus y0 equals the slope times x minus x0. So after you get this slope and plug that in there, you could just take one of these points and then plug a 5 in here and the 7 in there. And then have a 5 halves there. That's another route that you could go. And what some students are, if you have this formula memorized, then that might be a good route. It might get the answer quicker. Okay, so any questions?
Just a quick question. Does it matter which point you choose to substitute on the formula or no?
It doesn't matter. You just choose whatever you think is going to be the easiest. If it's going to make the calculations easier. That's all it is at that point.
Okay, thank you.
Sure. And also at this point, at this stage right here, we could have chosen this to be P2 and this to be P1. And then at this stage we would have -10 over -4, which those would reduce down to 5 halves. So that one would work out. So it doesn't matter which point you choose, but you have to be consistent about this right here. Okay, and you can't like choose the x value from one point and the y value from the other. That would just be, that's just crazy. Okay. So let's go on to number 12. Here we have a rectangle, has an area of 64 square meters. Express the parameter P as a function of the length L of one of the sides. State the domain of P. Okay, so you have a rectangle. And it doesn't have to have, all 4 sides don't have to be the same length, but you do have to have this and this being the same length, right? And then these 2 sides have to be the same length in order for it to be a rectangle. So the area is 64, but we also know that the area is the length times the width. Now they want the perimeter. We know that the perimeter is 2 times the length plus 2 times the width. Okay, because you start right here, go all the way around. You're gonna go across the 2 lengths, and you're gonna go across the 2 widths. And so that's what the perimeter is going to be. Now we want it only in terms of the length, L. So we have to get rid of this W somehow in this formula, and that's where we're at. So you come over here, and you know that the length times the W is 64. That means that W is 64 over L. So we plug that into there. And simplify. And then we see if that's going to work in I'm plugging it into Webassign, and that works. That's the first answer to Webassign. Okay, and then the second one is state the domain of P. So that is asking for what values of L. Okay, so what values can L be? Well, it's the length of a rectangle, so it has to be positive, right? It has to be positive. But what's the most that it can be and still be a rectangle? Well, And the area has to be 64.
Wouldn't it have to be? It could be 32, right?
Could it be 32? I suppose so. Hey, could it be any arbitrary large number? I guess so. If you had the
To be less than 64, right?
No, I was thinking about that. I thought that was my initial thought, that there had to be some limiting value, but now I don't think so. I think it could be really large, because W can just be really teeny tiny. So, like, if the length were 1,000,000. Wait, let's go 64 million. Let's say the length were 64 million. Whoa, that's a huge number. Well, you could make the width just equal to like something really, really small. It could just be, actually, I don't even do that. 64 over whatever the length is. And that gives me a value. It's going to be 1 over 1,000,000. The length has to be greater than 8. So I didn't write it here, but the problem says the length has to be greater than, the rectangle is longer than its width. So the length has to be greater. So that means that this rectangle is ruled out. The square is ruled out, because you can't have them all the same, because the L has to be more than the width. So it has to be greater than 8. Okay, so greater than 8. So A to infinity, try that one. Thank you for your help with that, by the way. Okay, so let's go to number 13. And they've got this window here that's the shape of a rectangle surmounted by a semicircle. So there's a rectangle there. And then on the top, it's got this semicircle. Okay, so that's just the top upper half of a circle. Okay, so the perimeter is 32. Express the area as a function of the width of the rectangle, of the width x of the window. Well, I'm confused again, because it says this is a rectangle, so this could be really long, and so I don't think the area is just going to depend on the length on this width x. Okay, so this is x. Okay, so area 2 up here is still going to be pi, or 1/2 pi r squared, which is 1/2 pi x over 2 squared. Okay, so that's going to be pi x squared over 8. That's area 2. Okay, now the perimeter. Now now let's take a look at this part right here. The perimeter is 32 feet, right? So if this part right here, we'll call that P1. Okay, so we know that this radius is x over 2, and we know that the perimeter of a circle is 2 pi r. That's the perimeter of a complete circle. This is just half a circle, so we cut that in half, so that's pi r. So that's going to be pi times x over 2. So that's pi x over 2. That's going to be this perimeter part right here. Okay, and then if we do this one, okay, we'll call this the height right here, and this is this right here. Then perimeter 2 is x plus 2h. Okay, so there's an h here, there's another h, and there's an x. So that's that. Okay, now both of these added together is going to be 32. Okay, so that means that 2h is equal to 32 minus pi x over 2 plus minus x, which means h is 16 minus pi x over 4 minus x over 2. Okay, so area 1, which is going to be x times h, that's the area of the rectangle, is going to be x times all of this. Okay, so the total area is going to be the sum of that and that. Okay, dang. Okay, let me somebody simplify this one here. So this is 16x minus pi x squared over 4 minus x squared over 2. Okay, so that's going to be this one plus all that. Okay, now this and this reduce down to pi minus pi x squared over 8. Let me see if that works. Yeah, that answer works. Okay, so this is the final answer right here. Okay, any questions about that one? Okay, so let's go on to the next one. Okay, here we're talking about even and odd functions. And so a function is even if f of negative x equals f of x. It has symmetry to the y-axis. And it's odd if f of negative x is negative f of x. And that will have symmetry through the origin. Okay, now f, based on the second part, you can see, oh, this f function here has symmetry through the origin, right? Because if you take a point here, then, and you go from here to the origin, and then you continue that same distance, you'll get another point on the graph. You can do this with any point on the graph. So that one, we'll come over to that and so on. You can go with at any point, or even like over here, you come over here to the origin and continue going, and you hit that point there. So symmetry through the origin. And the reason is that if that's x, okay, then that corresponds to this point right here that's in the vertical line with this point, then this point's coordinates are going to be x, comma, f of x, right? And if you have this symmetry like this, then this point over here, then this point here is going to be negative x. This value here is negative x. And the coordinates here are negative x, comma, negative, the negative of this one. Okay, but this coordinate is also f of negative x, because that's how things get qualified to be on the line, on this graph here. Every point on this graph, if you go to the x coordinate, then the y coordinate is going to be f of that x coordinate. Okay, so if this is negative x right here, then the y coordinate is going to be f of negative x. Okay, but it's also this because of the symmetry. The symmetry also gives you this one. So that's basically saying, so if you look at that and that, these y coordinates have to be the same, which is the same as saying that right there. Okay, so this is going to be odd, so you put that there. And then its reasoning is it's symmetric with respect to the origin. Okay, so symmetric with respect to the origin. And G is, likewise, G is even. And it's got symmetry with respect to the y-axis. And here, if you take a point on G and you go horizontally to the y-axis, continue on through, you get this other point here. Okay, but this coordinate here, let's say that's x. So this is going to be x, comma, g of x, because that's how you qualify to be on the line. And then this is going to be negative x right here. So this is negative x, comma, g of negative x. But they're at the same horizontal level, so that's the same as g of x. Okay, and so equating those two, wait, not those two. Equating these two is just this, but with the g. So g of negative x is equal to g of x. Okay, so that's odd, even, and odd functions.